Hello, Workplace Math 10 students. Today we're going to be looking at the first lesson on trigonometry itself. So just to show you what this lesson should look like and will be called in your Google Classroom, you should see a lesson called 7.2a, Trigonometry Part 1. And the assignment for this will be in Mathletics, and the assignment name is Hypotenuse, Adjacent, and Opposite. So basically, what you're going to be learning today is how to identify which side length is the hypotenuse, opposite, and adjacent in a right-angled triangle. So let's take a look at some examples here and work through this. So in trigonometry, we started off by talking about Pythagoras' theorem. And Pythagoras' theorem and trigonometry are similar and related to each other in the fact that both of them require you to be working with a right triangle. In other words, a triangle that has a 90-degree angle. And what we remember, hopefully, from this is that in a right triangle, there is a side that is directly opposite the hypotenuse, which is, is directly opposite the 90-degree angle, which is what we call the hypotenuse. Now, when we talked about Pythagoras' theorem, we then said that A side and B side are what we often refer to as legs. Now, in Pythagoras' theorem, we hopefully remember as well that if we have two sides that we know, so in other words, if we are able to see and know the one side length and know another side length, then we can then solve for what we don't know. So what we don't know can always be solved for using Pythagoras' theorem here as long as we have two side lengths. And that is basically, doesn't matter which two side lengths. So it could have been this side length and it could have been this side length, but as long as we know two side lengths, then we can always find the other missing one. So that's Pythagoras' theorem, and it worked quite well, and we discovered that and looked through that the last couple of lessons. Now, what we're going to look at here, though, is that with trigonometry, it allows us a little bit more. So what we see with trigonometry is it allows you to find the length of a triangle even if you know only one side length, as long as you also know at least one other angle other than the right triangle. And we're going to learn this term here, but this term for an angle that we don't know or we do know is something called theta. And this is just the Greek summation, Greek symbol for theta here. And so basically what we're saying here is that if we know, in this case, just one side length, so we just need to know one side length, and we also then know not only that it's a 90-degree angle, because that's what a right triangle always is, but we know one other angle in here, then we can solve for both missing side lengths. So this is sort of a step above Pythagoras in a sense. So what we're going to learn today is how to identify or start to identify how to work with trigonometry. So let's carry on with what we're talking about here. So trigonometry also, even if you have one side length and one angle that you know, can allow you to figure out all the side lengths. Trigonometry also, if you happen to know two side lengths, you can then also determine the angles of all of the sides of the triangle. And what I mean by that is, basically here, if we know this, so we know this side length, we know another side length, then we, using trigonometry, obviously this is 90 degrees here, this is always 90 degrees, this is a right triangle, it has to be a right triangle, but we can, using trigonometry, find out these two angles itself. So that's another benefit or another use of trigonometry, is to find out when we do not know a particular angle. So carrying on with this concept here, trigonometry uses specific terms for the three side lengths of a right triangle. So when we talked about Pythagoras' theorem, we knew that the side opposite of the 90-degree angle is called the hypotenuse. This has not changed. It's still called the hypotenuse with trigonometry. But now, when we talk about the angle that we happen to know, which in this case is theta, when we know this angle, the side opposite to that angle is called the opposite. And then whatever the leftover side is that is not opposite the known angle theta is the adjacent. So what I mean by this is we can see here that directly opposite of the right angle is the hypotenuse. So directly opposite that is always going to be the hypotenuse. That is a given. But now if we have a particular angle that we know, in this case what we call theta, then directly opposite of that angle, so it's not the 90-degree right angle, but directly opposite the other angle that we know, that is called opposite. And so we then clearly can identify hypotenuse, and we can easily identify opposite, and the leftover side is always what we call adjacent. Now you may say to yourself, well, who cares? But there is a real reason why we need to know this, and we'll see this in a second when we talk about the functions, trigonomic functions. So basically, in trigonometry, there are three specific functions, and you will see on your calculator something that says sin or sine, and you'll see cos or cosine, and you'll see tan, which is tan, and basically this stands for these three functions. And in essence, what these functions are is it's going to be determining what the opposite side length is divided by, that's what this line, the fraction line means, so opposite side length divided by the hypotenuse side length. Likewise, cosine is the adjacent side length divided by the hypotenuse side length. And tangent is the opposite side length divided by the adjacent side length. Now these functions can be easily remembered by thinking about this acronym: SAW, CA, TOA. And so what this tells us is that SAW, the S, stands for the function sine, and it's just reminding us that sine is always opposite over hypotenuse. And likewise, the C in CA stands for cosine, and that's reminding us that the A, that it's adjacent over the H, hypotenuse. And likewise, the T in TOA stands for the tangent function, and that's reminding us that it is calculated by taking the opposite side length divided by the adjacent side length. So hopefully that makes sense to you, and you can maybe remember that going forward. Now I have just one assignment for you for this particular part, and that's an assignment in mathletics called hypotenuse, adjacent, and opposite. So just clicking back over here for a moment, what you will see, and I might have to sign in here quickly, so just give me a moment. But what you should see basically is an assignment that looks, give me one moment here, an assignment that looks something like this. So it's basically asking you to determine, to figure out which type of, where the hypotenuse, the opposite, or the adjacent sides are. So if we look at a preview of this, this is basically the type of question you're going to see. So it's going to be asking you, it's going to be saying, hey, which is the adjacent side, or which is the opposite side, or which is the hypotenuse side of this angle? And once again, in this particular case, if we're looking for adjacent, what we need to consider here, once again, is we need to consider and remember that always opposite of the 90-degree angle is the hypotenuse. And that if we know this angle here, then the opposite of that angle we know is the opposite. And then therefore, the only other side that we still don't have is the adjacent, the leftover side. And so that side, AB, would be the correct answer here. So in this case, if we ticked off this and chose submit, it would say, hey, good job, you got that right. So let's walk through a few more of those, and let's just take a look at how that works. So I'll just erase off this so we can sort of see this a little better. So these are three examples from your mathletics assignment there. And so the very first one is this one here. So it's saying which side is the hypotenuse. So once again, this is really simple here. So the hypotenuse is always opposite of the 90°, which is indicated by this little line here. So the directly opposite, straight across from that, is this here. So looking at this, this is BC, and so the answer here is obviously this one here. So once again, that hopefully makes sense to you. The hypotenuse is very simple to determine and to find. Now, if we were to go to the next question here, that is this one here. It says, which is the opposite side to the angle theta here? Now this one, once again, requires us to look at the angle of theta, and that's this angle here. And remember that the opposite is the one that is directly across from, opposite of this angle. So in this case, that would be side AB. And so this would be our answer here. And lastly, we'll take a look at one more, which is the adjacent here. So this question here looks something like this. It says, what is the adjacent side to angle theta? And so once again, what we need to remember here is that we have the opposite, which is right here. So that's opposite. We have hypotenuse, which is directly opposite the right angle. And then the leftover angle, the one that is not opposite of the theta and is not the hypotenuse, is got to be this side here. So therefore, that is side AB here. So the answer to this is AB. So hopefully that makes sense to you. Give the mathletics assignment a try now. And if you have any problems, just like always, just do not hesitate to send me an email. Thanks very much for watching.